Yes, I. Yes, Aisha. Assalamu alaikum. How are you?
Walaikum assalam. Alhamdulillah, fine, sir.
All right. By the way, where you guys have been? Like, you guys have joined class so late today. Yes, Aisha.
I was attending weekly test.
Oh, okay, okay. Today you guys were giving the test. Okay. Okay, so let us continue from where we left the previous class. Up to calorific value we did learn in the previous class. Hope I'm properly audible.
Yes, sir.
Okay. So you do tell this thing to me that what did we learn in the case of calorific value? What did you understood? Yes, Aisha.
Yes, sir.
We were learning about calorific value in the previous class, and we did also learn how to find the calorific value. If you have a given mass of fuel, you can calculate its calorific value. So we did learn about that right now. Hope my screen is properly visible to you.
Yes, sir.
Mhm. So we did learn about calorific value that if you have a given amount of fuel, for example, exactly 1 kilogram of fuel, and how much amount of heat it will be releasing upon burning. So that is called as its calorific value. It's the amount of heat energy that a fuel would be producing upon complete combustion. 1 kilogram of fuel would be producing upon complete combustion. So that was called as the calorific value, and it is denoted in the unit kilojoule per kilogram. And we had the list of following calorific value of some common fuels given as follows. And we also know that an ideal fuel would be the one that would be having high calorific value, right? But there are other criterias also for an ideal fuel. Okay. So today we would be learning about the history of the matchstick. We'd be learning about the history of the matchstick, and we'd be learning about how a matchstick works. Okay, but before we do that, do one thing. Please read the given paragraph. Can you read the given paragraph about the history of matchstick?
Okay, sir. The history of the matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony, trisulfide, potassium,
Trisulfide.
trisulfide, potassium chlorate, and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. When struck, when struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of the match. However, where phosphorus proved to be dangerous both for the workers involved in the manufacturing of
Hmm.
matches and for the users. These days, the head of the safety match contains only antimony, trisulfide, and potassium chlorate. The rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous. When the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion.
Okay. So here it was you were reading about the history of the matchstick. So see, the history of the matchstick is about 5,000 years old. Uh, but the modern matchsticks that we are using, it was developed only about 200 years ago. Okay, na? So the modern matchsticks that we are using to this day, it was developed around 200 years ago. But the history of the matchstick is not just 200 years old, but it is about 5,000 years old. Okay, na? So earlier, how the matchsticks were used, what was the composition of the chemical used in the matchstick? So the thing was that, first of all, a suitable wood would be taken, right? And on the head of the suitable wood, what was being done? You'd be preparing a mixture of the following chemicals. In this one, this head of the matchstick, earlier, I'm talking about earlier how it was made. Okay, na? So earlier, chemicals like antimony trisulfide. Apart from this, there were some other chemicals, like there was potassium chlorate also. Okay, Aisha, potassium chlorate. And apart from this, there was another chemical called as white phosphorus, which is very deadly. It's a very deadly chemical. Okay, now it is highly combustible. So these were taken, and some glue was also taken. Some glue and some starch was also taken. So apart from all these, glue and starch was taken. Starch, you know what is a starch now? It's a type of carbohydrate, particularly found in potato, rice, etc. So we used to take all these substances and prepare a mixture of it and paste it on the top of the matchstick. Understood? Understood this now so far?
Yes, sir.
Okay. Now, when this was struck against a rough surface, like say for example, I am taking a rock for example, which has a rough surface. So if I were to strike this matchstick against the rock surface, so friction due to friction heat will be generated, and that heat was enough for the white phosphorus in it to catch fire. The heat generated due to striking this matchstick on a rough surface was sufficient for this white phosphorus to be ignited, and hence the matchstick will catch fire. It will start to burn. Getting it now?
Yes, sir.
Okay. But these days now, the white phosphorus has been replaced. These days, red phosphorus is used in place of the white phosphorus. So you might wonder about this question. Didn't you thought about this, like why the phosphorus, why white phosphorus in matchsticks were replaced with red phosphorus? Think about this. Yes, Aisha. What do you think? What could have been the reason why we replaced this? Why it was replaced? The thing is that the white phosphorus, it's highly unstable. It is very reactive in nature. Getting what I'm trying to say? It is highly unstable. Like if the temperature were to increase, like for example in the summer season, summer, what would be happening? The matchsticks would be automatically, it would be catching fire. If the temperature were to be very high, the temperature of the environment is very high. So since white phosphorus, it is highly reactive with oxygen. It is a unstable chemical. So thereby, on its own, it will catch fire. Even without being struck on a hard surface, on a rough surface, it will catch fire. So thereby, white phosphorus is now being replaced with the red phosphorus, which is a more stable chemical. You understood what I'm trying to say?
Yes, sir.
So nowadays, if I were to talk about the modern matchsticks, so in the modern matchsticks, antimony trisulfide is used. Okay, potassium chloride is also used, but white phosphorus has been replaced with, yes, Aisha, white phosphorus has been replaced with which chemical? Say the name. We did learned about it moments ago. It is in fact written over here. What's the name? Aisha, is the network connection stable? I guess my voice is reaching you properly.
Yes, sir.
Mhm. What's the name of this chemical? I guess you can read it. Yes, Aisha.
Yes,
That is red phosphorus now. So in modern matchsticks, instead of white phosphorus, red phosphorus is used. So far, I hope it is clear to you. Furthermore, on the box of the box in which the matchsticks are stored, so on the side of the box, there's a rough surface. This surface is made rough by adding powdered glass into it. So the glass has been crushed into powdered, it has been powdered, and that is added into it so that it is a hard surface, so that it becomes a rough surface. So upon striking the match head of the matchstick on this hard surface, the red phosphorus would be ignited. Okay, now also actually the thing is now what basically happens now, like when the modern matchsticks, by the way, the modern matchsticks are also called as safety matchsticks because they are safer than the previous ones. Earlier white phosphorus was were used, but now red phosphorus is used, so thereby it is more safer. So sometimes as matchsticks is also called as safety matchsticks. You might have heard of this safety matchsticks also. So what I was going to say that, yeah, I was saying now that once this is struck against the rough surface, so thereby it generates sufficient heat, and some of the red phosphorus actually converts into the white phosphorus. It converts into the white phosphorus. Some of the red phosphorus will be converting into the white phosphorus, and in this manner, it would be burning. The white phosphorus being more reactive than the red phosphorus, it would immediately catch fire, and hence the matchstick will burn. So that is the thing. Hope you guys are getting it. Read the given paragraph. Working of a matchstick. Read this.
working of a matchstick. The main component of the bulb of a matchstick is red phosphorus, which turns into white phosphorus on heating. White phosphorus spontaneously ignites, thereby increasing the temperature of the wood stem to the ignition point, and the matchstick starts burning.
It starts burning. Very good. So what do we observe here? The main component of the head of the modern matchstick is basically red phosphorus. Upon striking it against the rough surface, the phosphorus, it would be converting into the white phosphorus, right? And this white phosphorus would be spontaneously burning. It will ignite, and thereby further the temperature would be increased. It would be sufficient to for this wood to catch fire. So the wood will also catch fire, and hence the matchstick starts to burn in this manner. Did you understood this concept?
Yes, sir.
Can you explain this to me? Explain the working of matchstick to me. How do you how do you would be explaining this? Yes, Aisha.
The heat generated by friction when the matchstick is struck causes a mm, causes a minute amount of red phosphorus to be converted in white phosphorus.
No, no, from the beginning, you didn't talk about the composition of the head of the matchstick. Explain that also. Okay, start. Explain once again. You have in your explanation, you have to talk about the composition of the head of the matchstick also. Head of the matchstick, or basically the bulb of the matchstick. So first, explain about the composition of the matchstick. Okay, now then later on tell the then later on explain how it will be burning. Okay, once again. Yes, Aisha. Aisha, am I audible to you?
Yes, sir.
Yeah. Explain this once more. Aisha, tell me, have you understood this concept or not? Please let me know. If you haven't understood the concept, I will be happy to explain it once again. No worries about that.
I understood, but I'm not able to explain.
Okay, just explain the composition of the bulb. Like, what is the bulb of the matchstick made up of? Just that much only.
Uh, it's made up of potassium chloride,
Hmm. And
mm,
it's written over here. You can take help from here. And
and antimony sulfide,
antimony trisulfide. Okay, no? That is antimony trisulfide, potassium chloride. And then
white phosphorus,
nowadays we are using,
red phosphorus.
why?
Because because white phosphorus is
It's highly reactive with the air. Okay, no? Highly reactive, and it's unstable. Okay, no? It can catch fire on its own. Okay.
okay.
Okay, and of course glue will also be used. So glue and starch will also be used, right? So we make a mixture of it, we make a paste of it and apply it on the head of the suitable stem, suitable stick, right? Okay, then what will happen when I rub it on a rough surface? What will happen when it is struck on a rough surface? Then what happens? Read from here. Read from here. Read the first three lines.
The main component of the bulb of a mastic is red phosphorus, which turns into white phosphorus on heating.
Right. So when this will be struck on a rough surface, so due to friction, heat is generated right now. So that heat will convert red phosphorus into white phosphorus, and white phosphorus burns better than the red phosphorus. So it will burn further, and thereby the ignition temperature of the stem of the wood will be reached. Right now, sufficient amount of heat will be generated to burn the wood. So that is the thing. Hope you have understood this. Okay, what does the question says here? Can you burn a piece of wood or coal using a matchstick? What do you think? Can we do so?
Yes.
We can burn a piece of wood just using a matchstick. How is that possible? Like,
No.
have you ever tried doing so? For example, if I were to just have a piece of coal in my hand, even if I were to use the full packet of matchstick, I wouldn't be able to burn it. The reason being is that the ignition temperature of the wood or coal will not be met just by burning a matchstick. Getting it now? So the thing is that if I were to, I have to burn a wood. Like in winters, many times in villages, people would be sitting around a log of fire, or they would be burning some wood and would be sitting around it. But in order to ignite the wood, first of all, its ignition temperature has to be met. We did learn about ignition temperature. First of all, please define ignition temperature. Yes, Aisha. Define the ignition temperature.
Uh,
We learned that it is one of the necessary conditions for a fuel to catch fire. For a fuel to undergo combustion, one of the necessary condition was ignition temperature.
The lowest temperature at which a substance catches fire.
Exactly. That is ignition temperature right now. So thereby the ignition temperature of the wood or coal will not be met by burning a matchstick. Right now. So ignition temperature of wood or coal is not met by just using a matchstick. So thereby we will have to add some paper, some straw, some dry leaves, or some other things can be used to burn the wood. So because burning of lots of dry leaves or papers or some other things would raise the temperature, it will then we'll be able to get the proper ignition temperature for wood, and then it will be catching fire. So just a matchstick is not sufficient. Okay, answer this given question.
Red phosphorus.
Red phosphorus, very good. So it is used in the matchstick. Okay, now. Furthermore, why an activity? Let us understand a very interesting activity. Right now, moments ago, you defined the ignition temperature, right? So here, what we have done, we have taken two filter papers. We had made a cone out of the filter paper, and in one of them, we have poured some water. About 50 milliliter of water has been poured in one of them, and the other one is left empty. Both of them were placed over a burning a candle. What we saw that in the first case, the paper didn't catch fire immediately. In the second case, it would be immediately catching fire. What is happening here? You tell me, what do you observe from this? Like, what is happening here? Any clue regarding this? Why the filter paper in which water has been poured, it does not catches fire?
Because first the water gets evaporated and then it catches fire.
Exactly. Or in another way, we see that the heat is transferred into the water. From the paper cup, the heat is transferred from the water, because we know water is a very excellent conductor of heat. Water being a very good conductor of heat, so it would be absorbing the heat coming from this flame, from this candle flame, and thereby first it will start to boil and it will start to evaporate. So the paper will not catch fire unless all the water in it evaporates. So once all the water would have evaporated, then the paper cup would be catching fire. Got this now? So that is the thing. And how it is related to ignition temperature, because in the beginning when water was present in it, the ignition temperature of the paper was lowered. It was not met. But once all the water evaporated, so thereby now the ignition temperature of paper was met, then thereby it caught fire. Hope you have understood this activity. Okay.
Yes, sir.
And then the topic fire. Fire is basically it's a result of a chemical combustion reaction between oxygen and a given fuel. Right now. And fire is basically a kind of a result of combustion. In general sense, we can say it's a result of combustion. In most of the cases, whenever there is a combustion, fire will be given off. Okay, now. Furthermore, how long a fire will be lasting, it will depend upon the amount of fuel and the amount of oxygen that is available. On that basis, how long a fire will be lasting will depend upon. So hope that topic is clear. Then we were learning about control of fire also in the previous class, like how do we control fire. So we learned that fire can be controlled by removing any or all of the factors of combustion. So what are the factors of combustion? Yes, Aisha. What are the factors of combustion?
Fuel, fuel, heat.
Fuel, good. So by removing the fuel, we can control the fire. As you said, heat. Very good. So either we can cut off the heat or lower the temperature of the fuel, right? lower the temperature of the fuel and
Air.
air. So further, another thing which we can do, we can cut off air supply. So these are the necessary conditions. If we were to cut either one of them or all of them, thereby the fire would be turned off. So by any of above or all of above in this question, isn't it? So that is how fire can be removed. Now it's a common thing, like whenever a person is on fire, like whenever a person catches fire, so thereby a blanket is used to extinguish the fire. So what could be the reason behind doing this? Yes, what could be the reason behind this? Read the given paragraph. I shall read this paragraph.
Blanket cuts the supply of oxygen to the object that is burning, thereby prevents it from further burning.
Right now. So blanket is cutting off the supply of the oxygen. Right now, hence, because oxygen is a supporter of oxygen is a supporter of combustion. So once you cut off the supply of air or supply of oxygen, hence the fire would be put off. So that is the thing. Okay. We did learn about fire extinguisher. In the previous classes, we have learned about this. It would be a device that would be used by the fire brigades to control the fire. We did learn about the fire extinguishers, particularly the carbon dioxide fire extinguishers. Let us revisit these concepts. The first topic is that how do fire extinguishers work? So their main work is to basically cut off the supply of air or cool off the fuel below its ignition temperature. That is how most of the fire extinguishers would be burning. Like once you when you are using this carbon dioxide gas fire extinguisher, what does it does? Will it be reducing the ignition temperature of fuel, or will it be cutting off the supply of air?
It will cut off the supply of air.
Exactly. Or in this one, this person is pouring water over the burning house. So here he is lowering the ignition temperature of the fuel right now. So either two of the things will be done, right? So the most common fire extinguisher is the dry powder fire extinguisher, basically the carbon dioxide fire extinguisher. So how it works, let us understand. First of all, read the first paragraph, this one, dry powder fire extinguisher.
Fire extinguishers are devices used to put out
Aisha,
fire.
from this one.
Okay. Dry powder fire extinguisher. This type of fire extinguishers contain a mixture of baking soda, sodium bicarbonate, and bicarbonate, and sand. When you throw it over the fire, the baking soda decomposes by its heat to produce carbon dioxide. Since CO2 is heavier than air, it descends to envelop the burning flame and cuts off its contact with air and the oxygen supply.
Okay. So the first type of fire extinguisher, it would be containing baking soda. It would contain a mixture of baking soda and sand in it. Right now. So when you throw it over the fire, so what will be happening? Basically, the baking soda. This is the formula of baking soda, by the way. That's the chemical formula. Okay, now everything is made up of some chemicals now. So the baking soda is made up of chemicals, like it is made up of sodium, hydrogen, carbon, and oxygen. Together, it makes up sodium bicarbonate. This is called as sodium bicarbonate. So that is basically baking soda. Okay, now. So whenever baking soda is sprinkled over the fire, when it is thrown on the fire, so what happens? It will break into sodium bicarbonate, water, and carbon dioxide. The main thing of our use is carbon dioxide, and we know that carbon dioxide, is it lighter than oxygen or heavier than oxygen? Or in general, it is lighter than air or heavier than air? Yes. Yes, Aisha. Carbon dioxide, it is heavier than air or lighter than air. In the previous classes, as we have discussed about this, that as I told you, that whenever there will be fire, as of carbon dioxide gas, what it will be doing now? Like this, say some substances on fire. So it is burning, this substance is burning because has, it is in contact with oxygen. It is in contact with the oxygen gas. So in order to turn it off, what we do, we would be either in the first case, we have used the dry powder fire extinguisher. Basically, a mixture of sand and baking soda is thrown over it. Sand also helps to extinguish the fire. So thereby, you can use sand and you can you can use a mixture of sand and baking soda. So thereby, the carbon dioxide gas will be released. And carbon dioxide gas being heavier than air, it will form a blanket over it. And since it is heavier than air and heavier than oxygen also, thereby the oxygen gas will be displaced from here. It is kind of displaced from here. And the contact of oxygen or air is cut off. In this manner, it works. So hope that is clear. Next, we have the soda acid fire extinguisher. So let us understand about this one. Read the given paragraph.
Soda acid fire extinguisher. This fire extinguisher is a metallic cylinder which contains the sodium bicarbonate NaHCO3 solution. At the bottom of the cylinder, the concentrated sulfuric acid H2SO4 is placed in a thin sealed glass tube. A fixed wire gas surrounds this tube.
Yes. See, this type of fire extinguisher would also be working in the same manner by cutting off the supply of air, right? Also, it would be acting on all types of fire except of electrical and inflammable liquids, except fire that is due to electrical short circuits, or if some electrical appliances uh, um, have caught fire, or if there are some inflammable liquids, basically petrol or diesel like that. What happens here now? Basically, if you were to talk about the working of this soda acid type fire extinguisher, here it contains a bottle of sulfuric acid. It is sealed in a very thin glass tube. The glass tube is thin so that it can break easily. So in a very thin glass tube, we have taken an acid. Name of acid is sulfuric acid. And it's a concentrated acid, meaning that it's a strong acid, not a weak acid. Okay. So furthermore, it has been held via a wire gauge also. Like there's a mesh, you understand the iron mesh. What is an iron mesh? Yes, Aisha? So it is being held here in position via a iron gouge, a wire gouge basically, that is holding it in its place. Okay. Now, when the cylinder is inverted, when this whole cylinder would be inverted, and when the knob is struck, when this plunger, that is its knob, when this would be struck, so this knob will go inside this and it will break the glass. Try to understand what I'm saying. So as this will be pushed, as you invert this cylinder, and as you push the plunger or the knob, so thereby the knob will be struck against this thin glass and it will be broken. You understood this so far, Aisha, how it is
Yes.
working? Good. So while this will be broken, so thereby acid will come out of it now. The sulfuric acid will be released from it. Sulfuric acid will be released from it. Now further, we know that uh, this is containing this structure is containing sodium bicarbonate. That is basically baking soda. Remember sodium bicarbonate? Here also we did learn about sodium bicarbonate. where you were just using a mixture of sand and baking soda to extinguish the fire. Here you have also used the same chemical, that is sodium bicarbonate. But the thing is, here we are not using sand, but we have used sulfuric acid. So you tell me the sulfuric acid that comes out of this broken glass tube, it will be reacting with the sodium bicarbonate solution present in it now. Of course, it is going to react with it now.
Yes.
This whole region that you see over here, it is filled with the baking soda solution of baking soda. So the sulfuric acid will react with it. It will be reacting with it. Now, here's the interesting thing. Once the baking soda reacts with sulfuric acid, then in the process, carbon dioxide gas will be released. Carbon dioxide gas will be released in this process. Getting it now? So it releases carbon dioxide gas, and hence that carbon dioxide gas can be used to extinguish the fire. So as a result of reaction between baking soda, G is missing, baking soda and sulfuric acid, carbon dioxide gas will be liberated right now. And this gas, just you know about the functioning of carbon dioxide gas, how it basically works. It is heavier than air and it will displace the air, thereby cutting off the supply of air. So hope you guys have understood this. And in fact, this type of carbon dioxide, this type of soda fire extinguisher is the one of the most common fire extinguishers used. It will be you might find it out like if we happen to visit a multi-story, like in the case of like in you know we'd be finding this in like cinema halls, in schools, in offices, in multi-story buildings. We will find this kind of soda fire extinguisher. So have you understood this, how it works? Please let me know.
Yes, sir.
So carbon dioxide in a soda acid fire extinguisher is produced due to reaction of which two chemicals? The carbon dioxide produced here, it is formed due to reaction of which two chemicals?
Uh, sul sulfuric acid
And
and sodium bicarbonate.
sodium bicarbonate. Very good. And here the from this wax seal now, the carbon dioxide would be forcing the wax seal to open and it will rush out from the wax seal. Like basically this opening would be sealed using wax. Wax would be used to seal this. So when carbon dioxide gas would be formed inside this, so these carbon dioxide gas will force open the wax seal, and from here it will come with great pressure. And wherever you will be pointing out the nozzle, pointing out this, so there the carbon dioxide gas will be released. So hope you have understood this. Okay, now remember in the previous classes I have told you there's one more type of, like we have right now learned about the powdered the one. Previously we have learned about that one. Right now the dry, remember this one, dry powder fire extinguisher, we did learn about this. And we did also learn about how carbon dioxide gas will be released. Water, generally about water. Right now, let's learn about the foam type of fire extinguisher, how that one works. So please read the given paragraph.
Foam type fire extinguisher, like the soda acid fire extinguisher, it uses sodium bicarbonate solution. However, in this case, a substance called saponin or Turkey red oil is added
Hmm.
to the solution to produce foam along with the gas from the nozzle. Since this foam is lighter than oil, it floats on the surface of the oil and cuts off its air supply. Hence, it is very effective in putting out oil fires.
Hmm. Very good. So this should be working similar to the other ones also, but here we have used a special substance called as saccharin, or also called as turkey red oil. Okay, na? So in this one, what is happening? It uses sodium bicarbonate solution, that is baking soda is used. But in this case, a substance called saccharin or turkey red oil is also used. Turkey red oil is also added to the solution. Why? Because this solution would be producing foam. This solution, when it is this oil, when it is added to the solution, it produces foam along with the gas from the nozzle. So this whole setup would be same, but here we'd be adding some chemical called as saccharin. Okay, now so carbon dioxide gas will be released in this one also, but along with carbon dioxide gas, foam will also be released. Foam will also be released. Getting it now, Aisha, what I'm trying to say? So foam
Yes.
will also be released, and foam, it will float on the surface of the water, surface of the oil, I mean to say. And foam, as we know, it is lighter than the oil. Which one is lighter, like oil or foam? So of course, foam is lighter than oil, no? So foam being lighter, it will float on the oil also. So hence, it will be much effective. In that case, when the cause of fire is a liquid fuel, like if cause of fire is due to petrol or diesel or kerosene, so thereby this foam